Hello again. Welcome to another lesson in geometry. Today we are covering section 8-2, special right triangles. So we have some vocabulary here. First it says circle the segment that is the diagonal of square ABC, D. And our diagonal is going to go from one vertex to another. So it goes across the middle of our polygon. So AD would be a side, even though it goes from a vertex to another vertex. Okay? So underline the correct word to complete the sentence. A diagonal is a line segment that joins two vertices of a polygon together. Okay? All right. Complement is our vocabulary for today. We've seen this one already. Complementary is an adjective. So our math usage for complement is this. When the measures of two angles have a sum of 90 degrees, each angle is the complement of the other. So a non-example is two angles that measure sum to 180 are supplementary. So supplementary is two angles that add to 180, but these are definitely not complementary. Okay. All right. Complete each sentence with statement below with complement or complementary. If the measure of angle 40 and the measure of angle 50 for A and B, then the angles are complementary. Remember, if two angles have some that add up, complementary. Add up to 90, then they're complementary. Okay. So if angle A is 30 and the measure of angle B is 60, then angle B is the complement of angle A. Okay. And P and Q are complements because the sum of their measures is 90. Okay. All right, so if angle R has a measure of 35, then the complement of angle R has a measure of how much? So since they have to add up to 90, we can just do 90 minus 35 here, and that'll give us 55 degrees. Okay. The measure of angle X is 22, then the complement of angle X would be 68 degrees. Together they add up to 90. So if the measure of angle C is 65, then the complement of angle C would be 25 degrees. All right, circle the complementary angles. That means we need to find two angles that add up to 90. So 60 plus 40 is 100, and then it just gets bigger from there. 40 and 50 go together, so those are our two angles. They add up to 90. And we certainly can't use the 120 because it's already bigger than 90. All right, let's flip it over. Theorem 8-5, the 45-45-90 degree triangle theorem. So this is what's called one of our two special triangles. This is one of our two special triangles. And we're going to memorize these ratios for these special triangles. And you'll have to be able to use them in class to get exact answers. And the reason why we do this is you'll see these special angles, 45, 30, 60, and 90, show up over and over again throughout your math career. So they're really worth learning now. Okay. So in a 45, 45, 90 triangle, both legs are congruent. Okay. And that's because the extra two angles are equal. So across on them, their sides should also be equal. Okay. And the length of the hypotenuse is the square root of 2 times the length of whatever the length of the legs are. So for instance, if the legs were 11, then the hypotenuse length would be 11 root 2, just square root of 2 longer. So complete each statement for a 45, 45 degree 90 triangle. The hypotenuse is equal to the square root of 2 times the leg. And this is just something to memorize. So please don't come back next time saying, I don't get it. It's just really a memorization problem here. All right? So if the leg is 10, then the hypotenuse is going to be 10, the length of the leg, times the square root of 2. You just times it by square root of 2 to a leg to get the hypotenuse. All right, so finding the length of the hypotenuse, problem number 1. What is the length of a hypotenuse of a 45, 45, 90 triangle that has the length of a leg of 5 root 3? So one more time, the hypotenuse for a 45, 45, 90 triangle, we just need to memorize it. The hypotenuse is always going to be equal to the leg times the square root of 2. That's it. Okay? So our hypotenuse is going to be equal to the square root of 2 times the leg. And that's from our theorem, the 45, 45, 90 triangle theorem, one of our special triangles. Okay, so in this case, square root of 2 times our leg's length is 5 root 3. Let's see if I can make a better looking 5 there. So 5 root 3. Okay. And then we're going to do the commutative property of multiplication to get our roots together. So we're going to do this as 5 and then root 2 times root 3. And root 2 times root 3 is just going to be root 6. Okay. And that's going to be our final answer here. So 5 root 6. Because we cannot put the 5 together inside the square root, and the square root of 6 does not simplify. So what this allows us to do is find exact answers for our problems. Okay. Before, we would have had to estimate. So now that we don't need to estimate for these special ones that we are going to memorize. All right, so problem number 2, find the length of the leg in one of these special triangles, this 45, 45, 90 triangle. Okay, so the length of the hypotenuse is 10. So if I was to draw my triangle, this would be 10, and we know that these should be the same length. We have to figure out what they are, because these are 45-degree angles in here. So we're going to use our relationship before. So will the length of the leg be greater than or less than 10? Well, this is definitely going to be less. The hypotenuse is always the longest side. Okay, and in this case, it's going to be square root of 2 times longer. So we have our hypotenuse is equal to the square root of 2 times the leg. That's our special formula here. Okay, so we have to memorize that about this special triangle. So we don't know the, oh, I'm sorry, we do know the hypotenuse this time. The hypotenuse is 10. So we have 10 equals the square root of 2 times the leg. Okay, that's just a substitution for hypotenuse. And then we need to get the square root of the leg by itself, so we got to get rid of the square root of 2. So we're going to divide both sides by the square root of 2. So we have 10 over the square root of 2. Okay, and then that's going to give us this for our answer, 10 root 2. Now here is the problem. We are not allowed to have the square root of a number in our denominator of our answer. It's just a math rule. It makes everybody have the same answers in the end. So if we let square roots in the bottom, then somebody might put it on the top, and then we'd have two things that are very hard to tell were equal to each other. So we're going to do what's called rationalizing the denominator. We'll practice this in class next time a little. So we're going to times this side over here by 1, but we're going to pick a very special one to times it by. And that special one is going to be the square root of 2 over the square root of 2. So remember, any number divided by itself is just 1. So I am just timesing the side by 1, and timesing by 1 doesn't change anything. 5 times 1 still 5, 12 times 1 still 12, so forth. Okay, but this will allow us to get our square root off the bottom and move it up to the top. All right, so the square root of 2 times the square root of 2 is just the square root of 4. This is the denominator working out here. And the square root of 4 is 2. So notice we no longer have a square root on the bottom. Now we have 2. Okay? And on the top, we still have 10. It's outside the square root. And we have square root of 2 on the inside. All right, so square root of 2 on the inside, we can't do anything with. So we leave that as square root of 2. And then we could do 10 divided by 2, though. That works out fine. Those are both whole numbers. 10 divided by 2 gives us 5. So the length of our leg is 5 root 2. All right, now let's see why this makes sense to us to check. So both of these legs are supposed to be the same. Oops, that's a 5 root 2. Okay, so now we know our formula. The hypotenuse is equal to the square root of 2 times the leg, right? So our hypotenuse, which is 10 on one side, question mark equal to the square root of 2 times 5 square root of 2. Okay, so there's still 10 over here. And on that side, we have square root of 2 times square root of 2. So that's square root of 4 times 5. The square root of 4 is 2, so 2 times 5 is going to work out perfect for us and show that it does work when we check it. Okay? All right, so we need to be able to go backwards from the hypotenuse to the legs. Problem number 3, finding distance. So one more practice on our special 45, 45, 90 triangle. So you plan to build a path along one diagonal of a 100-foot by 100-foot square garden. To the nearest foot, how long will the path be? All right, so number 15, use the words path, height, and width to complete the diagram. So this is our path, the dotted line through the middle for our diagonal. This is the width of the garden. This is how wide it is. And this is the height of the garden. Okay. All right. So number 16, write L for leg or H for hypotenuse to identify each part of the right triangle in the diagram. So our path is the diagonal, which is the hypotenuse. And that means the height and the width are both of our legs. So I'm supposed to put an L there. All right. Let's look at the triangle in here to show this. So this really forms a 45, 45, 90 triangle. So we'll make it bigger up here. There's our right angle from right here. And then these are both 45 because the diagonal of the square has been split it right in half, those 90-degree angles in the other corners. This is going to be 100 for our height and our width. And then we don't know what the hypotenuse is, which is our diagonal. So for number 17, substitute for the hypotenuse and the leg. Let H equal the length of the hypotenuse, and then we know our leg is 100. Solve the equation, use a calculator to find the length of the path. So we're just estimating here. So we're going to do H equals the square root of 2 times 100 on our calculator. And estimate it out. And it's going to be about 141.42 and then 153 some other stuff, okay? All right, so to the nearest foot, what is the length of the path going to be? So this 4 will not make my nearest foot get bigger. So the length of our path is going to be 141 feet. Okay. All right, so we have our second special right triangle. This is a 30, 60, 90 right triangle. Okay, it's a bit trickier than the 45, 45, 90 because all the sides are different length. So this is also one that you need to memorize. That's just all there is to it. Okay. So the length of the hypotenuse is twice the length of the shortest leg. So this saying the shortest leg, which is across from the smallest angle, is going to be half as long as the hypotenuse, or the hypotenuse is going to be twice as long as it. Okay? And then the longer leg is going to be the square root of 3 times the shorter leg. So once I know the shorter leg, I can times it by the square root of 3 to get the long leg, or I could times it by 2 to get the hypotenuse. Okay? So complete the following statements here. Our hypotenuse is going to equal to 2 times the shorter leg, and the longer leg will equal the square root of 3 times the shorter leg. Okay? So you're going to need to be able to go between all 3 of these. So given one of them, find the other 2. All right? And this is just some memorizing. Make yourself a flashcard for it. Okay? Problem number 4, we're going to practice this a bit. Use the length of one side. What is the value of f in the simplest radical form? Complete the reasoning model below. Okay? So f is the length of the hypotenuse. I can write an equation relating the hypotenuse and the shorter leg doing 5 root 3, 3. So this is my shorter leg. And I want to find the long leg and the hypotenuse. All right, so our hypotenuse, remember, is equal to 2 times the shorter leg. Okay? And let's see. F, which is our hypotenuse in this case, is going to be equal to 2. There's our hypotenuse, it's length f. It's going to be equal to 2 times the short leg, and the short leg is 5 root 3 over 3. Notice it's not 5. This is the long leg. Okay? The short leg is always across from the 30, and the long leg is always across from the 60. All right, so then we have to go ahead and solve this, put it all together. So this is going to be 2 times 5 for 10 on top. We still have root 3. We can't multiply that in. Over top of 3 on the bottom. Now, if 10 and 3, the 2 numbers outside of the square root, could simplify, we would need to do that. But this is not, so it's be the improper fraction of 10/3. And remember, if we ended up with the square root in the bottom of our fraction in the denominator, we'd have to rationalize it and move it to the top. But that's not the case here either. Okay? All right. Let's flip it over and practice this a little bit. All right, on our last page, we have problem number 5, applying the 30, 60, 90 triangle theorem to a problem here. So jewelry making. An Artisan makes pendants in the shape of equilateral triangles. So that means we know that all of the sides of our triangles are the same and that we should have 60 in all the corners. Okay. Suppose the sides of a pendant are 18 millimeters long, and that's marked on our picture here. What is the height of the pendant to the nearest tenth of a millimeter? So our height is through the middle. Okay, we're going to try to figure that out. Circle the formula that you can use to find the height of the pendant. So let's think about this for a second. We're going to split this triangle in two to find our height here. So this is our height that we're looking for. Our short leg is going to be 90, and we know the hypotenuse is 18. Now we knew this was a 60 already because it was equilateral triangle. So 60 plus the 90 leaves me 30 here to make that triangle work out. So this is our special 30, 60, 90 triangle. And we have the short leg as 9, and the hypotenuse, which is always equal to 2 times the short leg, makes 18. So that works out fine for us. All right, so we need to find the long leg. Okay, so circle the formula you can use to find the height of the pendant. So we're not looking for the hypotenuse. What we're looking for is the longer leg. And the long leg's formula is square root of 3 times the shorter leg. So find the height of the pendant. So we know that the long leg, we'll call it the height, is equal to the square root of 3 times the short leg, which is 9. So our height here is going to be 9 root 3. There's nothing to solve there. But they do ask us in the next question to simplify this to the nearest millimeter. So we're going to pull out our calculator. Okay. And we're going to do 9 times root 3. So 9 times the square root of 3. And this will give us about 15.6 millimeters. All right, so lastly, we have a lesson check, and our lesson check goes back to the 45, 45 degree, 90 triangle. So one that gave you the most practice on, so you should be pretty good at this by now. So pause the video and see if you can do this problem. So here's we go. A test question asks you to find two side lengths of a 45, 45, 90 triangle, and you know the length of one of the legs is 6, but you forgot the special formula for the 45, 45, 90. Explain how you can still determine the other side's length. Okay, so even though we only knew one, we can find both of them in a 45, 45, 90. So underline the correct words to complete the sentence in the 45, 45, 90 triangle. The lengths of the legs are the same. That's why we really know 2. Okay, so we can do the Pythagorean theorem if we know 2 of the 3. So this was supposed to be 45 and 45. We knew that one leg was 6, but since they're across from the same angle measure, they both should have the same length. So 6 and 6. And then we're looking for our hypotenuse here. So we're going to do the Pythagorean theorem. So a squared plus b squared equals c squared. And I know in this case both legs are 6. So I'm looking for the hypotenuse. Leave x in there. So this will turn into 36 plus 36 equals x squared. That means 72 equals x squared when I simplify it. And if I square root both sides, I get the square root of 72 is equal to x, but we need to simplify this. Okay, so the square root of 72 is the same as 6 times root 2. Okay. All right, so the other two side lengths are 6 and 6 root 2, which makes sense to us because we know that the hypotenuse in a 45, 45 degree triangle should be the square root of 2 longer than a leg. So square root of 2 times 6, which is the same answer we got here. Okay. All right, so check off the vocabulary words that you understand. You should definitely have leg down and hypotenuse and right triangle and Pythagorean theorem. Those are all old ones, nothing new here. Now the big part, how well do you understand the special right triangles? If you aren't in here, you have 2 things you need to do. Number 1, you need to do some memorizing of those ratios. Okay, square root of 2 longer or 2 longer or square root of 3 longer and figure out which ones go where. And number 2, watch the video again. Okay, make sure you do these before you come back to class next time. So what we'll do in class is we'll practice finding the missing sides of our 2 special right triangles. And we'll also do a little extra practice on rationalizing the denominator, which was we had to do back here. Let's see if we can find it again. Down here on the bottom here. Okay, because this will be a little bit tricky and new for you guys. All right. See you in class next time.